On April 8, 1941, at exactly 2:35 in the afternoon, a massive aircraft rolled down the runway at Nakajima's test facility outside Tokyo. The plane was enormous, over 100 feet long with a wingspan stretching nearly 140 feet. 4 engines roared as it lifted into the humid Japanese air. Engineers from the Imperial Japanese Navy stood watching, their faces tight with anticipation. They had spent 18 months building this bomber. They had spent $950,000 buying the American airliner it was based on. They had faked a crash to hide what they were really doing, and now finally their creation was airborne. The pilot pushed the throttles forward. The aircraft climbed slowly, too slowly. The engines strained against the weight. The controls felt sluggish, unresponsive. Something was wrong. Something had always been wrong. The Japanese had stolen American technology, reverse-engineered the most advanced airliner in the world, and transformed it into what they hoped would be a strategic bomber capable of striking targets across the Pacific. Instead, they had built one of the worst heavy bombers in aviation history. This is the story of how Japan bought America's rejected airliner and turned it into a spectacular failure. It is a story of espionage, deception, engineering hubris, and the dangerous assumption that copying someone else's work is the same as understanding it. It is a story that begins not with war, but with the golden age of American commercial aviation. The year was 1935. Commercial aviation was transforming America. Airlines were expanding routes. Passengers were growing more confident in air travel, and aircraft manufacturers were competing fiercely to build the next generation of airliners. The Douglas Aircraft Company had just introduced the DC-3, which would become the most successful commercial aircraft of its era. But even before the DC-3 entered. Service. The airlines were already dreaming bigger. William Patterson, the president of United Airlines, approached Douglas with an ambitious vision. He wanted an aircraft that would make the DC-3 look like a relic. Patterson envisioned a 4-engine airliner capable of crossing the entire continent without stopping for fuel. It would carry 42 passengers in daylight service or 30 in sleeper berths for overnight transcontinental flights. It would have pressurized cabins so passengers could fly above the weather. It would have air conditioning for comfort. It would represent the absolute cutting edge of aviation technology. The proposal was audacious. No airline had ever operated a 4-engine landplane for commercial passenger service. The technology Patterson was describing barely existed. Building such an aircraft would require solving engineering problems that had never been tackled before. The risks were enormous, the costs would be staggering, but the potential rewards were equally impressive. Whoever built the first successful 4-engine airliner would dominate commercial aviation for a generation. Douglas was intrigued but cautious. They knew the challenge would stretch their capabilities to the limit. They agreed to proceed only when other airlines expressed interest. American Airlines wanted in. Eastern Airlines joined the consortium. Pan American Airways and Transcontinental and Western Air, which would later become Trans World Airlines, also committed to the project. Each airline contributed $100,000 toward development costs, creating a $500,000 fund to support the most ambitious commercial aircraft ever attempted. The engineering challenge was immense. Douglas assembled a team led by some of their best designers. Arthur Raymond, who had led the DC-3 program, took charge of the effort. The team faced problems that had never been solved before. How do you build a wing strong enough to support 4 large engines while remaining light enough to fly efficiently? How do you design landing gear that can handle an aircraft weighing over 60,000 pounds? How do you route fuel lines, hydraulic systems, and electrical wiring through a fuselage that must also accommodate passengers in comfort? The questions multiplied as work progressed. How do you pressurize a cabin at high altitude without creating structural stress that would lead to metal fatigue? How do you provide enough auxiliary power to run air conditioning, cabin lighting, and galley equipment without overloading the electrical system? How do you train pilots to fly an aircraft twice as heavy and twice as complex as anything they have operated before? The team worked for 2 years. They produced 8,100 drawings documenting every aspect of the aircraft. They built a detailed wind tunnel model and conducted 866 separate tests, totaling 1,100 hours. They studied airflow patterns, stability characteristics, and control effectiveness at speeds and altitudes that no previous airliner had achieved. They used 1,300,000 rivets to assemble the prototype. The total engineering effort was measured at 500,000 man-hours, an unprecedented investment for a commercial aircraft. What emerged was unlike anything the world had seen. Douglas called it simply the DC-4. The aircraft was a marvel of innovation from nose to tail. It was the first large aircraft with tricycle landing gear, meaning it sat level on the ground rather than tilting back on a tail wheel. This seemingly simple change had profound implications. Passengers no longer had to climb uphill to board or walk downhill to exit. Cargo loading was easier. Ground handling was more predictable. The aircraft looked modern because it was modern. The nose wheel design would eventually become standard across the industry, but in 1938 it was revolutionary. The wing was massive, spanning over 138 feet from tip to tip. It had to be that large to generate enough lift to carry the aircraft's weight while maintaining acceptable landing and takeoff speeds. The wing design borrowed from the proven DC-3 but was scaled up dramatically. 4 Pratt & Whitney R2180 twin Hornet engines were mounted on the wings, each producing 1,450 horsepower. The engines were positioned with noticeable toe out, meaning they were angled slightly outward rather than pointing straight ahead. This unusual arrangement was designed to improve stability by creating favorable yaw moments during single-engine operation. The tail was perhaps the most distinctive feature. Instead of a single vertical stabilizer like most aircraft, the DC-4 had 3 vertical fins, one in the center and one at each end of the horizontal stabilizer. This unusual configuration was chosen for a practical reason that illustrated the constraints commercial aviation operated under. The aircraft was so large that a single conventional tail would have made it too tall to fit inside existing hangars at airports across the country. Airlines could not afford to build new hangars at every destination. The triple tail kept the overall height manageable while providing adequate directional control. It was an engineering compromise dictated by economic reality. Inside the fuselage, the DC-4 was designed for a level of luxury that commercial passengers had never experienced. The cabin was wider than any previous airliner, allowing for more comfortable seating arrangements. Passengers sat in chairs that actually